Good morning. I'm Altaf Hussain, a former professor, Department of Chemistry, University of Dhaka, Bangladesh. I plan to prepare AS and A-level chemistry lecture series, and this is our 24th lecture on equilibrium. So we'll be talking in last few slides about equilibrium. Well, before we start equilibrium, we have to remember what is reversible reactions, and then we continue equilibrium. Let's see, there's a picture here. This is copper sulfate with 5 molecules of water. And when we dehydrate it, it is also copper sulfate, but it's no water molecules in it. It can react to reform the original reactant. We call this reverse reaction. This instance, heating and adding water not being carried out at the same time. Okay. However, there are chemical reactions in which forward reaction and backward reaction can be simultaneously happen. In many chemical reactions, the reactants are not used by completely. That's what we also know. So this, when we do not use reactants completely, we have to find out theoretical yield in it. A mixture of products and reactions are formed. The product react together to reform reactants at the same time. As the reactant are forming products, this type of reversible reaction is called an equilibrium reaction. We use, as I said, we use this sign to say about equilibrium in chemical reactions. Next slide. Let's consider a reaction where hydrogen gas and iodine gas reacts and form hydrogen iodide gas. This is also a reverse reaction. We can from hydrogen iodide gas, we can go to hydrogen gas and iodine gas, and as well as from hydrogen gas to iodine gas, react together, we can form hydrogen iodide gas. This is a schematical picture to show you how it is happening. This is what is hydrogen atom, and this is the iodine atom, and then what we have, this one is hydrogen iodide gas, and we show it how it is going on. Well, you see, when fizzy drinks are made, what we do, carbon dioxide is dissolved in drink under pressure. When we take off the lid, we see the bubbles of carbon dioxide suddenly appear. Again, when we put the lid on, the bubble stops. This is because of the equilibrium reaction of carbon dioxide gas and carbon dioxide aqueous media. The forward reaction happens during manufacture, and the backward reaction happens when we open it. What are the characteristics of equilibrium then? Equilibrium will be pillared on 4 particular features under constant conditions. Equilibrium is a dynamic one, but does it mean dynamic? Dynamic equilibrium means that the molecules of ions or reactants and products are continuously reacting. Reactants are continuously being changed to products, and products are continuously being changed to reactants. This is a dynamic process. Characteristic equilibrium condition, it must be dynamic. Well, equilibrium reaction has 4 particular features under constant conditions. As I said, one is dynamic, the other one is the forward and reverse reaction occur at the same time. Forwards and reverse reaction occur at the same time. Okay, at equilibrium, the rate of forward reaction equals the rate of backward reactions. That what is molecules or ions, reactants are becoming products, and those in the products are becoming reactants at the same time. Okay. Then another factor, that rate of concentration of reactants and products remain constant. The concentration remains constant because at equilibrium, remind it, at equilibrium, the rates of the forward and backward reactions are equal. That's why the rate of concentration and reactants and products remain constant. When it remains constant, we call the reaction is at equilibrium. When you start by either using a mixture of colorless hydrogen gas and purple iodine vapor, or using only colorless hydrogen iodide gas, then we also see the backward reaction, forward reactions are same, the rate of reaction is same, the concentration of the reactant and products are same too. Well, next point, the fourth one, the at equilibrium, it requires closed system. Fourth criteria. This is what we say closed system. This is open system. So if we have a closed system, then reactants and products are not escaping. But if it is open system, you can see that here the carbon dioxide gas is going up, going away from the system. So a closed system is one in which none of the reactants products escape from the reaction mixture. In an open system, some matter is lost in the surroundings. Chemical reaction can be started without placing them in a closed content. They can reach equilibrium in open flux if the reaction takes place entirely in solution and not in gas, and no gas is lost. So what does it mean? That we can have a open system, but therefore in that the reaction should occur and there should not be any gas in the reaction system. Position of equilibrium. The equilibrium position may change. So we will find out how equilibrium position change, reaction equilibrium position change. The position refers to relative amounts of products and reaction present in the equilibrium. Position of here, what it does, it refers to the relative amounts of products and reaction present in the equilibrium mixture. If the system in equilibrium is disturbed, how can we disturb it? By change in temperature and in the concentration of the products increases relative to the reactants. We say that the position of equilibrium has shifted to the right. If we change the temperature, if the concentration of product decreases relative to the reactant, then we say that the position of the equilibrium has shifted to the left. Mind it, we can shift the position of the equilibrium to the right or shift to the left depending on concentration and change in temperature too. Well, change in concentration, temperature, and pressure, if reactants or products or gases affect the position of equilibrium. And this effect has been studied by Henry Le Chatelier. So we will use his law, his observation, and see how a dynamic equilibrium system changed. One or more factors affect the dynamic equilibrium is changed. The position of equilibrium moves to minimize this change. When we predict the effect of changing concentration and pressure by referring to the stoichiometric equation of the reaction, we can predict the effect of change in the temperature by referring to the enthalpy change of reaction. We discussed it, and we discussed enthalpy in other lecture. How does a change in concentration affect the position of equilibrium? We'll start one by one, saying how concentration is affecting, how temperature is affecting, how how other factor, pressure, is affecting the equilibrium, dynamic equilibrium change. When the concentration of one or more reactant increase, reactant, mind it, the reactant, we say, if the reactant is being changing concentration, the system is no longer in equilibrium. If we change the concentration of the reactants, one of the reactants or both reactants, that the system will no longer be in equilibrium. The position of equilibrium then moves to the right to reduce the effect of increase in concentration of the reactant. If we increase the concentration of the reactant, then equilibrium moves to the right of the reaction, the forward reaction, there is forward reaction, and this effect increases the concentration of reactant. Well, more products are formed until equilibrium is restored. So these are the 3 points when we change the concentration of one or more reactants. Well, when we change the concentration of one or more products, what happened? Again, we lost equilibrium. And in that case, what is happening? That the equilibrium moves to the left. Why? To reduce the effect of the increase in concentration of product. And more reactants are formed until equilibrium is restored. So if we, as I said, if we change the concentration of equilibrium, change the concentration of the position of the equilibrium, and change the concentration of one or more reactants, we have 3 possibilities. Immediately, the equilibrium disturbed, and then if it is reactant, the equilibrium move to the right, and this effect increase of concentration of reactant, and we get more products are to be formed to maintain equilibrium again. Similarly, a power product, then we see that equilibrium destroyed, and the equilibrium moves to the left. Why? To reduce the effect of increasing in the concentration of product, and more reactants are formed. Okay, then we go to then we take this particular example and to see what happens with a specific example. We are taking ethanoic acid and then ethanol, and then we get a ethyl ethanoate and water. This reaction is in equilibrium. Let us take an example. If we add more ethanol, that is reactant, one of the reactant, we add more ethanol. What happens? According to the Lee-Schaffer's principle, some of the ethanol must be removed from the system. Some of the ethanol must be removed. Why? We have to remove that because the concentration of added ethanol, to reduce the concentration of added ethanol. And in that case, the equilibrium shifted to the right, as I said, as I mentioned earlier. And what happened? More ethanol reacts with ethanoic acid, and more ethanol, ethanoate, and water are formed. So, increasing the concentration of ethanol, one of the reactant, we see that the position of equilibrium goes to the right, and more ethanol, ethanoate, and water are formed to restore the equilibrium again. What happens if we does the water add water in it? Then similar thing. If we add water in it, the equilibrium is destroyed. And Le Chatelier's principle said this must be water must be removed to reduce the concentration of water. And then what we have to see that equilibrium shift to the left and more ethanoic acid and ethanol are formed. What happens if we remove some water? We add some water, you can remove some water, that must also increase, must add also some its concentration to increase the concentration water, and then position shift to the right again, and more water and ethanoate are formed. Okay. And then we come to, we have been talking about concentration, saying how concentration affect the equilibrium. Now let's take about how pressure affects the position of the equilibrium. If we have a gas here, the container in gas, and then we see that if higher the pressure, the higher the concentration. If we lower the pressure, the lower is the concentration. So pressure of gas is caused by what? How pressure of gas is caused? Because molecules of gas hit the wall of the container. Each molecules hitting the wall to the containers contribute total pressure. So at constant pressure, the more gas molecules there are in a given volume, the higher will be the pressure. Well, we are taking an hypothetical reaction. X is gas, Y is also gas, and then the product Z is also gas. And both X 1 mole, Y 1 mole, and Z 1 mole. This above hypothetical reaction, 2 moles of gas on the left and 1 moles of right. When pressure is increased at constant temperature, mind this now, that if we increase pressure, we have to keep temperature constant. Okay, the molecules are close together because the pressure has increased. The position of equilibrium shifts to minimize this increase. It shifts in the direction of fewer gas molecules. Here, it shifts in the direction of fewer gas molecules. Here, the fewer gas molecules, so it shifts in this direction. Okay, more product Z is formed, and X and Y until equilibrium is reestablished. And if it shifts to the direction, we have to have more product of Z, so to get the equilibrium reestablished. If there are equal numbers of molecules of gas on each side of the equation, so let's say there are 2 moles, and if we would have 2 moles here, what happened then? Then there is no change if we change the pressure. If a reaction involving gases and liquids, when that is a point, if a reaction where one reactant is gas and liquid, and the product is also solid, something like that, if this is the position, then it is only the molecule gases that count to determine its pressure or affecting the equilibrium position. Okay, this chapter, equilibrium, is a little bit having more and more points in the syllabus. So we have to take another 2 or 3 lectures on equilibrium to complete it. We will talk about equilibrium constant and how equilibrium constant changes, etc. In the next lecture, we will finish this equilibrium chapter, and thereby finishing physical and inorganic syllabus of AS level. In this equilibrium chapter will be finished within 2 or 3 lectures more. Thank you very much.